This is the third video in the Working with Model data module, and in this video we'll be looking at using sequences. And a sequence is a way to define entity routing. It's a mechanism that we can use to specify a series of nodes that an entity visits. And we'll look at sequences using a couple of different symbits and a couple of models. The first symbit we'll look at is the entity follows sequence symbit, and I already have that pulled up here. Here's the symbit, and I've made a modification of this symbit to get us started so that we can talk about the basic idea. So we have an entity and a source, three servers, and you can see that the links coming out of the server there are alternative. So leaving server 3, entities can either go to the sink or to server 2. Leaving server 2, entities can either go to the sink, server 1, or server 3, and so on. And so if we build the model and don't change any of the default parameters, what we see is that entities choose probabilistically which route to take. So which path they take emanating from a transfer node is going to be determined probabilistically. The idea behind a sequence is that I'd like to be able to define a specific node visitation sequence. And in this model, in this symbit, the visitation sequence that we'd like is for entities to go from the source to server 3, from server 3 to server 2, server 2 to server 1, and then server 1 to the sink. Now clearly for this model, since we only have one entity type, the easiest way to do this would just be to get rid of all of these extra paths. So get rid of the paths from the source to server 1 and get rid of the path from source to server 2, and then the entity will clearly go directly to server 3. But that's not what we want to do, because we'll see in the second symbit where we'll introduce alternative entity types that we want to be able to specify different sequences or different node visitation sequences for different entity types. So using sequences is basically a three-step process. First, we need to define the sequence, and we'll do that using a sequence table. Then we need to assign the sequence to the entity. In this case, we only have one entity, so we'll assign the sequence to the default entity instance. And then finally, we need to tell the transfer nodes that we want to route the entities using the sequence. So if we go to the data, first step here is to define the sequence table, and you can see that the sequence table is defined when we select the single. There's only one column in this one. It's called, let me expand this a little bit, we're using a sequence destination property. And so this type of property we use by adding the sequence table. So we can't do it by adding a regular data table and then doing the property. We have to do the sequence table, and we'll discuss why that is as we move forward. But basically we created the table, and we have the destination node, and we simply specify that node visitation sequence. So we said that we wanted to go from the source to server 3 to server 2, server 2 to server 1, and server 1 to the sink. And so we're doing that by going to the input nodes of each one of these entities. So step 1 is to define the sequence, and we did that with the table. Step 2 is then to tell the entity to use the sequence. So the method we're going to use in this symbit is just go to the default entity definition, or the instance definition, and change the routing logic property, initial sequence, to sequence. And so now every time a run space is created of this instance, it will be attached, or there will be a reference to the sequence table. The final step is to go to the transfer nodes. If we select the transfer node going out of source 1, we can see the entity destination type is set to its default value of continue. We want to simply change that to say, instead of continue, we want to use the sequence. And so now, since the sequence is defined, and when the entity is created, it gets to the transfer node, it will then use the sequence defined in the table. The final step is to put the by sequence modifier or property on all of the transfer nodes. So I'm going to just choose them all the remaining ones, and do by sequence. And so now we have our sequence defined, we have the assignment to the entity, and then we have all of the transfer nodes. And so when we now run our model, instead of being routed probabilistically, the entities follow the sequence specified in the table. So again, a very straightforward process once we have the sequence table defined. So for our second example, we want to introduce this notion of having additional part types. As I said, for the first sim bit, we didn't really need sequences. We could simply implement the sequence using paths. In our second sim bit, which is entity follows sequence with table, we have 3 part types you see. And what we want is each one of the part types to have a different sequence through the servers. So let's grab that one, entity sequence with tables. Here we go. Here's the model. And the use of sequences follows the same basic steps. We have to define the sequence. In this case, we have 3 different sequences. We have to then assign the sequences to the part instances, and then we have to update the transfer nodes. For this model, I didn't update the symbit, so it already all works. You can see when I click on Go here, we can see that we get the routing that's specified with the label here. So looking at how this was developed, if we go to data, in this case we have 4 tables. We have our 3 sequences, our sequence for type A, our sequence for type B, and our sequence for type C. And we also have a job table that we use to specify the type. So as we did in the previous videos where we have a entity type and then we have a product mix, and then we use that entity type and product mix in the source to generate random observations. In this case though, we have an additional column that specifies which sequence to use. And so we look at this new column and its type. Scroll over, see if I can grab this guy, make that a little bigger. We can see this is a sequence table property, and so associated with each part type we have defined a sequence. Similarly, the process time, we use a expression property, but we're using a reference to the corresponding table. So if we go back to our facility and have a look at how this is implemented, we can see when we look at the source, we have the table reference that we've seen before, where we use the random row property to a random row function to get a random row from the table, and then we have the part type specified by that job table. The additional reference that we have here is after we create the entity, we create a reference to the corresponding sequence table. So we have the job table reference. Once we have the job table reference, then this part sequence column will identify which sequence we assign. And so by assigning that table reference, because these are sequence tables, Simio knows that the entity is assigned the corresponding sequence. And so the all of the transfer nodes have the by sequence modifier set. And so when we create an entity, the reference to the job table is created, that reference to the sequence table is assigned by that second second table reference assignment. Now note that this is fundamentally different than having a reference. So these tables, or I'm sorry, having a relation. These tables have no relation to one another. So the job table and the sequence table are not related, but we just store the table, the second table, the sequence table, as a column in the job table. In our next example, we'll look at doing something very similar, except we will be using relational tables to essentially achieve the same thing. The next sequence example is Model 7.2 from the Simio and Simulation textbook, which is a modified version of the emergency department model. The emergency department model 7.1 from the previous videos, we modeled the clinic as a single server. In this case, we're going to expand that so that we have a sign-in area, a registration area, and then trauma rooms, exam rooms, treatment rooms. And we have the different patient types will require or will follow different routes through our emergency department. So the routine patients will go from the source to sign-in, from sign-in to registration, registration to exam rooms, and exam rooms out. The moderate and severe patients will go to the treatment rooms after the exam. The urgent patients will go directly from sign-in to the trauma room to treatment room. So very similar to what you would see in a real clinic, other than the fact that we made all of this up. But basically, what we want to demonstrate is the fact that we can use sequences to specify the routes that the individual patient types take through our emergency department. So since we have 4 different patient types, we could take an approach similar to the previous model, the Symbit model, where we had um, separate sequence tables for each sequence. But in this case, instead, we're going to use the table relationships. And what we will do is we will have a single routing table, right? A single sequence table. And you can see we have added, in addition to the sequence, we have added 2 additional columns. One is the treatment type and one is the service time. And so we took our patient data table from model 7.1 and we made the patient type as a column key. So we're going to relate the 2 tables using the patient type as the key. And then in the treatment table, we have a foreign key to that patient type data type. And so we have the sequence, the node visitation sequence, the treatment type, and then we also have the service time so that we can specify the service time or the treatment time by patient type and by step in the sequence. And so when the patients are created right here in the facility, we go to the source. Note that we, as we did before, we just have a link to the patient table, but that since the tables are related, the entities have an automatic reference to the routing table or the sequence table, right? So in the previous model, we set that reference. In this model, that we get that reference automatically through the table relationship. So once an entity has a reference to the patient data table, the entity also has a reference to the corresponding component of this treatment table. So going back to look at our data, if we look at the patient data, for example, and look at the master detail view, we can see that when a patient has a reference, an entity has a reference to the row 1 of the patient table, that entity also has a reference to the corresponding sequence, and so that entity will be routed from the source to sign in, from sign in to registration, registration to exam rooms to exit. And if a patient is type urgent, then it will follow a different sequence. But that sequences are all stored in a single table, and the individual entity type sequences are managed through the relational table. And so when we run, we can then see that the individual entity types will take the corresponding sequence. So at any point in simulated time, each entity can only have a reference to one sequence, but it's possible to change that reference. Clearly the reference changes as the entity progresses through the sequence, but you can also change the sequence reference itself. So to demonstrate that, I'm going to use the Symbit choose alternate sequence and talk a little bit about how that works. And so the basic idea of this Symbit is that we have an operation, a serial processing line, server 1, server 2, server 3, followed by an inspection, where the normal course of flow is through the 3 servers to inspection and to the sink. But if the entity fails inspection, then we want to go back to adjust and then restart the sequence. So the way we're going to do this, if we run while I'm talking about, you can see what's going on, is when an entity fails inspection, we changes to red and then it goes to the adjustment. So what we're going to do is we're going to define 2 separate sequences, a normal sequence and then an adjustment sequence. And so go to our data, and you can see that the normal sequence is exactly what I mentioned. The source to server 1 to server 2, and so on till we get to the sink. And when we fail inspection, what we want to happen is instead of going to the sink, we want the entity to go to adjust and then back to server 2. So at this point, we need the entity to change the sequence. And our second sequence, or what we call the adjustment sequence, simply has one node, the input to adjust. And so when an entity fails inspection, we want it to just take this sequence instead. And so we achieve that through an add-on process for the after processing. So after the entity processes, we execute the add-on process, where we simply decide probabilistically, just 70% chance that the entity is good, and the 30% chance we use the set row. So the set row step says I want to set a row or set a reference to the adjustment sequence table. And because the adjustment sequence table is a sequence table, is a sequence table, then the entity will then follow that new sequence. And so leaving the inspection, instead of going to the sync, it will go to adjust. Once we finish adjust, we want to restart the normal sequence, but we want to restart the normal sequence at server 2. So the way we do that is we set the reference back to the normal table, but we don't start it at the beginning. So when we look at our table, instead of setting the reference with row 1, we're going to set the reference to row 2. And so if we look back at our model, the transfer node here has the destination type set as continue, so it's not using the sequence. It will just automatically go to server 2. And because the sequence reference is set to row 2, now the new reference, so we go to the process here, and that's done with the set row here, set row normal sequence to 2. Because it's set to row 2, the entity's now at server 2, and so when it comes to the next node, the output node, it simply increments the reference and tells it to pick up and go to server 3. So in this case, we've mixed the two different routing strategies. One is using the by sequence, and then the second one is the continue, and then restart in the sequence, but not at the beginning. So to summarize the use of sequences, again, it's a three-step process to use a sequence. The first is to define the sequence, which we do with a sequence table. The second is to assign a reference to that sequence table to the corresponding entity. And finally, to set the transfer nodes, the corresponding transfer nodes, to use the by sequence property for entity routing. Also note that through the symbits we looked at, we demonstrated how we could change the sequence, we could restart a sequence, and we could actually start a new sequence at a different location other than the first entity. So sequences are quite powerful for doing entity routing, and there are several other symbits that demonstrate the use of sequences, and you should definitely have a look at those and make sure you're comfortable with the application of sequences.